Welcome to this talk of mine about deploying pluggable space things. I'm here to talk about the space component system we made for the Rubicon release, where we basically developed a new system to get away from old legacy problems we had with extending existing things in space. So we used them for the mobile structures, like the mobile depot and the mobile tractor unit, for instance. So let's start by introducing myself. So I'm CCP Frelligus. I'm a programmer for the awesome team 5.0. Yay! And that's actually like the in-game avatar for our team. That's Xagan, Fossi, Nobody, Frelgus, that's me in the middle, Masterplan, Batik, the token check, and then Labowski, our resident QA. So, what are we going to talk about? I'm going to give you a brief history of why we went into developing these space components to begin with, and what kind of problems we were trying to get away from. And then I'm going to go more into the space components themselves, basically what they are and how they work. I'm going to give you a few statistics over how they have been used on TQ since release. And then I'm going to end with going over a few interesting use cases you guys have developed on TQ. Give a few examples. So let's just get started. So since we started developing EVE Online, we have, like for 10 years, been adding things to space. Like we have stargates, suns, planets, asteroids, and all kinds of things, even spaceships. Probably seen some of those. So what most of these things have in common is that they are all represented by a destiny ball, which is basically the physics unit used by our destiny physics engine. Probably very familiar with that one, at least to some extent. So on top of that, going to be a bit technical for a while. We have a base entity, which basically is wrapping this destiny ball and basically allows us to hook up all kinds of logic through Python to implement these different behaviors they exhibit. And they usually tend to inherit this base entity to special what it does. So this allows us to share code between these things and implement common functionality. So this looks pretty simple, right? But after 10 years, this starts to show cracks. It becomes a bit more messy, and actually it looks more like this. So these are basically the actual inheritance hierarchy we have. So that's a lot of different classes inheriting different things. And so in order to share code between different branches of this tree, this inheritance tree, we start to move code around so that it can be shared. And it usually follows a pattern, or more of an anti-pattern, of moving the shared code to the base class. And what you actually get out of that is a base class that has a method list which looks sort of like this. So all this code that's meant to be shared among different things, which are quite different in the or in different places in the inheritance hierarchy, it effectively becomes a dumping ground for all kinds of code, unrelated code. So we have over 150 methods to deal with all kinds of crap. So everything knows how to like launch a missile and attack things, and like even a space cloud. So and and this becomes problematic when you're trying to like change the behavior in one end, and it goes through the base class and actually ends up changing something completely different in some other things. So yeah, that's a little Lord of the Rings code. So to give you a more concrete example, we created a thing called the personal hangar array, which is sort of like a corporate hangar array. Like it's a structure and it's in space and does all of those things. But we sort of wanted to function more like a planetary customs office, which had that functionality of being able to keep track of individual people's inventory. But like the planetary customs office isn't even in that hierarchy, which is also another problem. So sharing code between them became pretty much impossible, and you ended up having to do a special case for that, and not able to really reuse much of that code, which is sort of bad. Another example would be like drones. And we all like drones, especially the server. And so we had drones at some point, and you would send them off to attack a target at some distance. And then along the way, it goes and decides it's going to do something completely different. Suddenly, the pirate rat AI kicks in, and it decides that this is just a stupid target, and it's going to do something completely different. So you suddenly have like code from a different branch affecting something where we don't want it. It becomes really messy, and a lot of the entity code suffers from this because they have all kinds of shared variables which you don't really want to be shared between these very, very different things. So another class of problems we have with these within our code is basing things on the type system. So like everything you buy in the market and everything you fly and everything you fit and everything you shoot is basically a inventory type. So you have types, and then you have groups like battleships, and then you have categories like ships or modules and such. And what you start seeing in code, if you base it on that, is that you get a lot of weird exceptional cases. Like suddenly you want to avoid a behavior in one specific case, but not another case. And perhaps yet the third case wants to do something completely different. And you get like these if-else statements that become really complicated, really weird, and you have no idea what it's supposed to be doing or what it's doing at all. So what do we do to get out of that situation? And that's pretty much where like space components come in. So we sort of wanted a method that does not rely on this inheritors picture and doesn't rely on hard coding type knowledge into the logic itself. Because when we want to do an exception, it just becomes progressively more complicated. The complexity of the code goes up, and it becomes a maintenance burden in the end. Like it becomes more costly for us to develop even simple things because of this. And also, I don't really want to extend the physics ball. It doesn't really have much to do with the actual space entity other than doing the physics itself. So we developed this component system, which is sort of like a Lego system, where you don't have a centralized class at all. So you can decouple the behaviors themselves. Like the inventory doesn't mess with like the AI of the thing or what it's supposed to be doing, it becomes easier to share those where you want them. So, and we can also data drive this to a much better extent. So our designers can author this by themselves as long as we have actually made the components. So we built up a library of components that they can just attach to whatever type or whatever group or whatever category they see fit. And we don't have to reprogram game code or debug weird if-else statements to get the correct behavior we want. So we also wanted something that could actually work alongside the existing thing, because realistically, we're not going to rewrite 10 years of history for a single release. And because we were doing mobile structures, which were a completely new type of thing, but we wanted to do some of the existing behavior, like some of them have inventory, and you should be able to throw them into space and retrieve them and stuff like that. And also, it made it much easier to be testable. We could actually unit test this code rather than this weird concoction that's inheriting from a C++ physics class somewhere along the way. So we don't have any good way to actually test that within our code base. So to give you a better understanding of maybe how this works. So a component is basically a set of data that describes like how it's supposed to work. And that's like per type, really. And then you instantiate that in-game and can mess with the code or mess with the variables after that. So it contains state as well. And in general, we have like a system that works on a component. And actually, the physics engine is pretty much clean example of that, even though that's not actually a component at all. So we have the Destiny physics engine, and that works on these Destiny balls. And it doesn't care what else that ball does. It just cares that it has a mass, it has a velocity, it has some speed, and it has some size, so it can do its collision. So that's actually a nice example of a clean component until we put that entire huge structure on top of it, which does weird things. But it's not always clear like what exactly what is a system and what not. But we don't have to be too worried about that. So a component looks something like this. These are actually how we did these structures. So on top there we have the mobile Cynosural inhibitor. And it has a deploy component, it has an activate component, it has a decay component. And these are pretty self-explanatory, except maybe the dogmatic one, which is a bit funny. So the deploy component actually allows us, basically defines the behavior of allowing you to launch this into space. So if it has this component, you can throw it out of your cargo into space, and it contains the parameters like the restrictions, where you can deploy it, how far from a gate, how far from each other, and that kind of stuff. The activate one defines the little activation cycle you get when you throw them out, the time, and also manages triggering or basically messaging to the others that the object has indeed activated. The decay just controls that it does indeed decay over time. And if you skip that, it will never decay on its own. So either you have to destroy it or pick it up. But you can only pick it up if it has a scoop component, like the mobile depot has over there. And that also has, so they have different components, but there is no base class. There is no mobile depot class anywhere to be found. There are just these components. And then we have the data file that describes like what that type, what components that should have, and what parameters we should give it. So this is more how it looks then on the in the runtime system. So for each solar system, we have a component registry And there we associate components to an inventory item ID. So it's just a key that has these components. So if we need to know like the value of some parameter, we just check with the registry, does it have this component and does it have a value that we can use. They use a messenger, which is basically a publish-subscribe mechanism, which allows the components to send messages and to receive and subscribe to messages. And this is mostly used for like within an item. So a mobile depot will basically be spamming its other components if they want to listen to some event, like the activation or the reinforcement or something like that. And the systems can also do that. Like at the ballpark, basically the thing that runs the whole physics show and a lot of other things. When you put it into space, you get an event. When you remove it from space, you get another event. So like the messaging becomes more targeted than what we have often done before, which is just like spamming events to the entire node. Like this thing did a thing, and nobody really cares except this one class somewhere. So this becomes a bit more targeted. So what did we achieve by doing this? Well, we got very testable code. We could unit test almost everything, at least on the server. The UI code is a bit more of a mess to actually test. But we got very low defect rates. We have had very little fallout from this, and most of that is more like mechanic related, like edge case we oversaw or messed up somehow. And it's pretty easy to add a new component because they're not dependent on like a huge hierarchy of things that you can mess up. You just add a new thing and it does its thing pretty much in isolation. And it just interacts with the system it has to interact with. There's no like 3,000 line code files anywhere that need to be like taken into consideration. So, and the designers can create new types using all the existing components without us having to do much. So that's mostly just if they want new functionality, we have to create a new component, but that's pretty basic. Like new functionality doesn't materialize out of thin air. So that's fine. And yes, some hilarious usage of mobile structures also came out of this, but we'll go into more of that later. So let me give you some statistics on how this has been used on TQ to date. So the first one here is the number of items created per day. And you can see that the mobile tractor unit is pretty much by far the most popular one, followed by the mobile depot. The others hardly register in the grand scheme of things, but they are used. If you look at the deployments per day, we're getting almost like 60,000 deployments, like whenever you put them into space each day. And again, most of that is actually the mobile tractor unit, by far the most popular, maybe the most useful. But if we remove both the mobile tractor unit and the mobile depot, which is the red line there, this is the rest of it. By far fewer, but these are also much more specialized things. But the top ones here, the blue one and the red, those are actually made by our sister team, SuperFriends, which is the siphon structure and escrow. What's it called? The ESS, yes. The acronym works much better, yes. Why do you invent so long names? I don't know. Encounter surveillance system, it says it right there. But these are more like how to be a dick to other players, which is good. That's what we like, right? So another statistic is how much has been destroyed of these things. So in total, like from kill mails from the beginning of these things, like 1.3 million, a trillion ISK has been lost or destroyed. And almost all of it is the mobile tractor unit. And I'll give you an example of that. There are some pretty big kill mails for those floating around. So, we're gonna skip this one. So let's go into some like more anecdotes, examples of what has been done. Let's start with a mobile Cynosural inhibitor. One of the best uses seems to be denying reinforcement, maybe not entirely unobvious. And there are good examples of catching big prey, and that's actually a thing exploding. I picked out of a YouTube video. That's an Archon being destroyed, and a few minutes later, another Archon was destroyed because they just managed to put up another Cyno inhibitor just after it landed, like seconds after it landed. Very bad timing for the Archon, very good timing for the, I think it was Black Legion. So that's fun. The mobile depot. So after launch, we got some pretty interesting results in Cheetah. Like it was flaring red for a while, as that comic clearly states. I really like that one. I picked that out of Reddit, I think. And then I think that's actually from TQ. I can't prove it though. Showing titties in space. And I know that somebody actually used, tried to use the micro jump unit to bridge between stations in Cheetah. Tried to get the entire way. I think he fell a bit short, but he tried. That might actually be that line over there, I don't know. But that's pretty fun. Some other uses is players have been using it, for instance, to fit warp stabs when doing missions to get away from people trying to kill them, which I guess is fair. Also refitting racial ECMs during gate camps to better jam your prey. Very good. And of course, doodling, which is titties in space. At least it's not a penis. So, great balls, eh? That brings us to the mobile tractor unit. And one of their favorite pastimes seems to be looting during fleet fights. That's where you get the biggest kill mails. A very interesting story was when somebody put an ESS inside an anomaly to bait people. They spawned tons of rats to try to get them killed. And then they went into a pod to collect the loot, or to basically to spawn the loot. And then they had a mobile tractor unit to fish it out of harm's way. But somebody caught wind of this, so they had their own mobile tractor unit to try to snatch it from the others. So it became a cat and mouse game inside an anomaly, fighting over the loot from an ESS. Quite interesting. But one of my favorites, I never found the actual source. It was from a podcast, but I couldn't actually get the right one. So I think this happens in a wormhole system. And they set up a pause and put up no force fields and try to bait people in to come and kill the pause. But it so happens that it's a fully operational battle station. and they put a mobile tractor unit inside a ball of batteries. So people jump in, get slaughtered by the station defenses, and then just pull in the loot automatically. And this very much reminds me of Star Wars somehow. So that's pretty interesting. I actually think the next one is the final slide. I have been running through this a bit quicker than I expected. That's actually this over here. This is from a very notable fight. Yeah, they say it's a Titan-sized sum there. But the sad thing is that we only get to know how much gets lost and destroyed, and what I really want to know is how much they get away with. Like, who got the biggest catch out of one of these? That's what I want to know. Probably pretty hard to actually get this off the field. It's going to be like full of Titan modules and stuff, big stuff. Probably need a freighter or something. But that's sort of it. So thanks for all the fish. Thanks for coming. If you have any questions, I will take them now. Thank you. Yes, just come take the mic again.
Are space components our hope for modular pulses?
That is actually a quite unrelated topic. Mobile structures are not the replacement of pulses. Components might very well be used to get there, but no, I can't really promise anything on that.
So is the component system you developed just used in the mobile structures at the minute?
Yes.
Yes.
Currently, it's just used in the mobile structures.
Will you be sort of like upgrading the old stuff?
Well, yes, that is the plan. I mean, how we did it means that we can factor out individual things and put them into components and remove them from that hierarchical mesh that you saw there.
So you develop components to meet for different specialities, or so you build a item up out of these Lego bricks.
Yes.
So say. Okay. Cool.
Yes.
And there's no base involved at all, is there then?
There's no base class, no.
No. Well,
no.
But not. So you've got the Destiny sphere. That's a common component between them all. Is it still?
Yeah, it's still there, but that's now just it's a physics thing. So if you need to interact with that, you just call that up through Destiny. I mean, they're all in space in a system, so they usually can get to the physics system and get the ball, because they all know who they are. They all have the item reference.
So how is your final class actually created then? If you said earlier that it doesn't technically exist.
So what happens is that when a thing gets put into space, basically that's an inventory, a low-level inventory movement. The ballpark basically takes the recipe for the type, because it knows the type information at that point, and creates all the components and registers those to that item ID. So at that point, all the components are in existence. If you need to get access to those, you need to know basically what item you want to talk to. Or you can go and iterate through all of a specific component, but we haven't had an example of that yet.
Symbols it on the fly, basically.
Pretty much. But from a template, so we map from types. Each type that we have components for gets created at that point. So, thank you.
So I guess this would go with the dogmatic component. Mobile depots in particular can be deployed from a cargo hold, but not from a fleet hangar. Is that an oversight, or is there a reason behind that?
That is a design decision, really. I mean, these were designed as personal deployable structures. That was sort of like the base design for these. So they are meant to be something that you put out yourself. So we do that from the player cargo ship. But I mean, I guess we could do that. I mean, if the designers feel that's warranted. But no, we didn't. It wasn't really an oversight.
Hi, my question was kind of based around the usage statistics that you presented.
Yes.
Has there been any talk of rebalancing some of the modules? For instance, the one that comes to mind is a D-scan inhibitor. Since you can't scoop it, maybe, and it's not getting used as often now, maybe reducing the price point or the material manufacturing cost for it?
Yes, we have discussed that, and I know that this is in the back of our designer's mind, but we haven't done that yet. But that's very true. Some of them may have a unfortunate price point that doesn't it prevents them from getting used properly. But Fossey can probably answer more about that if you ask him afterwards.
I'm just glad he's in the audience then.
Thank you.
My question goes to a little bit more on the technical side, as currently we can't have Alliance bookmarks, mainly due to a technical issue with that Alliance don't exist, sort of. What are the technical limitations to modules that we could have that you can think of? Like, is ownership an issue technically, or?
For components?
Yes, for example. Like, right now, they're only for personal use, but eventually they're going to be for co-op use. And
yeah,
stuff
okay.
Like
so you think of mobile structures. So there's no, or there is a technical limitation in that our role system is pretty inadequate to properly deal with that. And we had plans on actually tackling that, but we haven't gotten there yet. So we didn't want to roll this out to like corp or fleet or other types of like group behavior, because that would have complicated that whole thing quite a bit. But there were plans, but I can't promise you anything. But we had ideas of using this for more like group-oriented stuff as well. Yes.
So far, that's the only technical issue you have run into.
This, I mean, this. Yes, I mean that's more of a pragmatic problem. We don't want to compound an already messy situation too much, but we want to solve that. But like components don't really limit you in any specific way, but they allow you to just decouple behaviors to make it more easy to do stuff. It may actually be quite a bit more easier to actually do this with roles when we actually get to it. But we want to have a better infrastructure in place before we start creating weird code again.
So when we start hounding Fossey, we just need to stick clear rules and rights, and then everything else is a green light, basically.
Almost.
Almost. Well, that's what I'm sort of trying to find out. What is also off limits, sort of currently?
Off limits. I mean,
due to technical restrictions, of course.
I mean, not much. I mean, it's just like what features are we trying to push at every time? Like what is it that game design wants to work on? I mean, if you're gonna redo functionality in shapes, you might actually use some components for that, because you can actually add those alongside whatever we have currently, and get that out of those base classes, because they can live side by side, and that's one of the nice things. We managed to actually get that without causing a huge pile of mess, which is good.
Thank you.
Thank you.
Hi, this could be a pretty technical question, so I'll just ask you to speak briefly to it. The component system, is that something you guys just kind of designed from scratch based on the needs that you had, or did you take inspiration from some kind of software frameworks that you were looking towards?
A good question. So I was going to mention this in the slide, but I forgot. Like a component system is nothing new, really. Like it's been used in all kinds of things. It's used in business and games and all kinds of things, and often referred to like an entity object system or a component object system. And this and our own implementation is actually highly inspired by implementation, a games object manager from I think it was Games Programming Gems 4 or 5, I think. So it's a very lightweight framework itself, but like you don't feel the urge to use something like that because it's pretty abstract to think about it that way. When you come out of school and you're like, class hierarchy is the best thing, like object-oriented programming solves everything, but often it doesn't. They have their place, and this one actually fits very well for like complex games. And like Unity have their own game objects, but they're different. They have a base like game object, and that keeps track of the components rather than like a registry like we do, which is sort of global for the node or for the solar system. So hope that answered your question.
Hi, can you tell us a bit about the performance impact of this new architecture? Have you compared it against the old inheritance hierarchy? So are there any benefits or differences that you've noticed?
We haven't done a comparison directly between components versus the class hierarchy. But in terms of memory, it's probably slightly higher because there's a bit of overhead for having each component with all their values. But it hasn't been impacting us in any way. Like the thing that has been impacting us is more us coding stupid things. Like we had issues with the mobile tractor unit having inventory locks and stuff like that, and then we could get into problems which caused and we were checking the inventory way too often, stuff like that. But that's more an application problem rather than something inherent to the component system itself.
So you're planning on maybe refactoring the old code to use more of the component system going forward, or do you just plan on leaving the old code as it is?
Well, it's more of a, if we need to work on some aspect and need to change it, then that's a good opportunity to move it into a component. There are things I want to just break out and put into components and migrate into more of that structure.
Yeah.
But as the other structure gets simpler, it becomes also more manageable.
Yeah.
So I hope that's a good overall trade-off.
Yeah. Thanks.
Thank you. So if there are no more questions, I would just like to thank you all for coming. You've been a great audience. So, thank you.